Awesome. Cool. Let me share my screen. Cool. So this whole session is about coprocessors. Why coprocessors? Like, why should dApps use coprocessors? So let's first understand and let's first intro. So I'm Gajesh. I work at Eigen. I do DevRel and engineering. We have Ismail and Mo from Lagrange and Brevis. Awesome. And yeah, so let's understand like how this is like Web2 before 2000, like it is a synchronous architecture. Like you have to send one web server, like one request at a time. It's a monolithic server which does it all, and like it's not scalable. Then comes the modern web architecture where there's a web server which does async calls to like all these specialized services. And now we have Web3. Now we are worse than Web2. And also I want to give a huge shout out to Brevis for stealing their slides. No we are making like synchronous calls to smart contracts, and it's like it replicates it's like replicated compute, replicated storage, and like high communication overhead. And like you can't do like all these kinds of like different activities where now like if Uniswap wants to give like 50% discount to whoever who has done like 10,000 trades or $30 million in volume last 30 days. Like you can't implement that. Like you can implement that, but it takes 8 hours and 40K in fees, which is actually there's more. Um yeah, and it's like no trust-free access and like updation of short logic data. Now coprocessors makes it like super simple. Now you read the data, like you make a SQL call or like use SDK, like request it off chain, and then like it's submitted on chain after like computation is done. Cool. Now what things can be built with coprocessors? Before we started with this, does anyone have any questions? Oh, okay. Um, awesome. So like we'll go like category wise, like each app category. So let's start with lending. So like you can do payback history, like based on payback history, you can give them fee-based discounts, like and you can have fixed rate lending, like P2P lending. Um, yes, and then there's farming where you can this is something like I'm really excited about, like where instead of like doing the compute on chain, you can just request this off chain and like you save a lot of gas. And then there is trustless point assurance. Uh, and we have like other categories like DEX and perps. So like within DEX, you can have like volume-based discounting, like which we discussed before. You can have rebating and like farming boosts. So like in case you swap like $10 million, you're going to get like 10% more rewards in your liquidity pool. Yes, then perps like I'd actually want Ismail or Mo to like expand more on the Oracle and funding calculations here.
Yeah. So
Yeah, sure.
that's a very
Yeah, go ahead.
Yes, that's a very good segue, Gajesh. And so one of the very interesting things that you can do with coprocessors is to take certain types of compute that you would have historically offloaded to a trusted or an economic-based or a centralized off-chain oracle, and you can instead prove those in zero knowledge, for example, directly to your contracts. So things like volatility, things like moving averages of price, these types of primitives can now be accessible directly by DeFi applications without having to rely on a set of trusted third parties with economic guarantees or some type of POA guarantee. It can be fully trustless and fully ZK.
Awesome. Mo, do you want to add anything to this? or the whole slide?
Yeah, precisely. And for the specific a specific example for that, for most of the perpetual swap protocols on chain these days, the funding rate update is actually calculated mostly in a centralized fashion. So basically, they take the Chainlink Oracle's price feed, which is used as a reference price for the for the spot price, and then they use like the internal perpetual swap price, and they actually kind of use an off-chain oracle to actually read that on-chain data and put it back to the blockchain to actually calculate what is the difference between the perpetual swap price and the spot price to actually get the funding rate. So, however, funding rate is actually very critical in perpetual swap, because if the funding rate is wrong, then the price will actually diverge towards that direction that you don't want it. You don't actually want to you want it to diverge. So with this very simple example, you can actually save the you don't actually need to calculate the on-chain price, especially on the perp side, in a off-chain fashion. You just kind of directly access this through coprocessor and do the calculation of the funding rate also in the ZK land. So end to end, you get this kind of a trust-free funding rate calculation process.
Right. Yeah, so yield indicators, like this is actually really interesting. And like right now, if you see, like if you want to move, if you want a yield indicator which moves around like USDC is the best lending pool, like on maybe Blast, for example. Like this is not like if we want to actively like change pools and like move it to the best yield source, then it's not like you need to trust like external party. But like with coprocessors, you can basically query like multiple different pool pool APYs on chain and then like move the liquidity around. On the active liquidity management side, this is more related to Uniswap V3, if I'm not wrong. And Ismail can or Mo can add on this.
Yes. So if you look at existing active liquidity management solution today, they're essentially building on-chain hedge funds, right? So like the idea is that a user gave the or delegate the fund to these active liquidity management solutions, and then they will, let's say, put it in a Uniswap liquidity position and rebalance that when the price moves. However, the challenge here is that these active liquidity management solutions today are actually built with very, very simple kind of on-chain fund management algorithms. The reason for that is that the decisions made by these active liquidity management solutions are right now centralized and trust-based. So let's say very concretely, if they're moving the LP position and rebalancing the LP position based on price move, that price move is detected entirely off-chain and determined by solely by the ALM solution to say, okay, this is the time to move the liquidity. But no one can actually hold them accountable if they actually deviate from the protocol. So using ZK coprocessor, what you can achieve here is you can, again, have this type of end-to-end trust freeness in the whole management process to say, okay, I'm moving your liquidity, not because I want to, but because I can prove to the blockchain with a ZK proof saying that, hey, look, the price in Uniswap's TWAP protocol, TWAP oracle has already moved across certain threshold that you predefined. Right, so that's one thing that you can immediately make the active liquidity management protocol trust-free using coprocessors. And the second is that you can actually make, and build a lot more exciting strategies in these ALM solutions. Now you can actually build very complex machine learning-based, decision algorithms to actually track various different input parameters to actually move the liquidity around. And you can still prove to the user that you're executing these actions based on a predefined, pre-committed algorithm. And the better thing, the best thing here is that you don't actually need to review everything about the model itself. You can hide certain weights in the model to say, okay, like, these are some things that I don't want to review, but I can tell you that this is a model of this type, but there are some weights that is hidden. And you can basically, convince the user you're moving users' liquidity based on this predefined and fixed algorithm. So like this actually opens a lot more exciting use cases in the ALM solution space.
Yeah. So Rohan? All right. So to add to that, fundamentally, any yield aggregator on chain is constrained by the data that it can access as decisions, the movement of liquidity, as well as the types of computation that it can overlay on top of that data. When you are designing a yield aggregator and active liquidity management solution on chain today, you're fundamentally constrained by the gas limits and the amount of read operations you want to make from storage. So you can't access transaction data. So you can't do something like a VWAP. You would need to rely on a strategy manager that either decisions based on entirely off-chain logic or maintains the same security principle that they currently do, where your decision based on on-chain logic, and therefore has a decision based on a constrained amount of data that it can read. And so this means that at the end of the day, the results that a user gets in terms of the performance of their portfolio is inferior to what they would have if they opted in to reduce set of security assumptions, like using a centralized off-chain entity to orchestrate their liquidity, which is fundamentally a trade-off we don't want in this space, where you have to find a way to accept either worse returns or better security. What you can get to with a ZK coprocessor, specifically one that's oriented around offering offering contracts the ability to ingest large amounts of data and compute over large amounts of data, is the ability to develop systems that perform in a way that is comparable to how you would otherwise decision liquidity orchestration or the movement of capital between strategies in an ideal off-chain context. But you can do that trustlessly on-chain. So to another point I see listed here on VWAPs, this is actually a very interesting concept that you can actually unlock with a ZK coprocessor. That is something that is not possible on chain today. And that is access to event logs. So currently, your contract is constrained to access exclusively to storage slots that it can call from view functions from other contracts or that are stored within the given contract. You cannot access event data, historical or from the present block. What you can do with a ZK coprocessor is to prove the computation over this data. So if you, for example, can say, what is the volume weighted average price based on all the swaps on this pool or these series of pools over the last 10,000 blocks? And if we look at how collateral is priced on chain today, like if we look at how the most used Chainlink fees, they're all VWAPs. The usage of TWAPs or time weighted average prices in crypto has been something that has been often talked about, but seldom utilized. I think Euler made an attempt at this several years ago, year and a half ago, 2 years ago, and it unfortunately fell through on governance. And so the majority of these protocols currently rely on Chainlink VWAPs. What you can do with a coprocessor, specifically one that can do large-scale compute over event logs, is do actual on-chain VWAPs, whether that's for options protocols, whether that's for pricing collateral lending apps, or whether that is for decisioning on yield aggregators or active liquidity management strategies. Oh, Gajesh, you're on mute, I think.
Yes. Yeah. Also, like, feel free to take the options and bridges component.
Yeah. So what you can, in fact, do with bridges is quite interesting with a coprocessor is you can prove the inclusion of transactions or event logs that are contained in a block header if you have access to that block header across chain. So, for example, think of an OP rollup that has access to the L1 block header, just natively from a pre-deploy on that chain. Every OP rollup has this. And there's talks of other optimistic stack solutions and ZK stack solutions adding similar pre-deploys. In this situation, you can simply introspect into that block header to check the inclusion of a message or an event that might have been emitted cross-chain, or the inclusion of a transaction that might be included in one of the most recent block headers. And so this gives a rather powerful principle where if you can access a block header cross-chain, which can be thought of as a commitment to the chronology of that chain, anything that has historically happened in that chain, including bridging actions, including messages, you can check without having to rely on a third-party protocol.
The only security you have to have is the authentication of that initial block header. And there's many instances that we actually find within crypto today where you have pre-authenticated block headers that exist in the execution client. You have rollups that commit their state roots on L1, and you have other rollups that can natively read those state roots. So you have this morass of block headers that you can, in theory, with a coprocessor, in practice with what we build, our coprocessor, you can in fact compute over and check the inclusion of relevant information within. Oh, Gajesh, I think you're on mute again.
Sorry, can you also add more on the volatility and options part?
Sorry, which part? The volatility? Oh, yeah.
Yeah.
So if we think of how one would price an option, let's say Black-Scholes or some other measurement or some other mechanism for pricing an option, you require real volatility. Real volatility is not something that you can access today within the execution client. I mean, you can get implied volatility, and this is what most options derivatives protocols on-chain rely on, but real volatility would currently require access to an off-chain Oracle solution or something along those lines. So with a coprocessor, you can in fact find volatility directly from any liquidity pool that you want to compute it over, simply by finding the standard deviation of that price going back over some historical period of time. And this means you can start actually having options protocols on chain that would price that option in a comparable way to how you would in a more traditional TradFi context, which increases the types of DeFi instruments that we can now support in a trustless way on chain.
Awesome. Cool.
And just one more thing to add on the bridge side, from kind of a practical point of view, if you guys are familiar with existing bridges, you know how ZK coprocessor will change this is that if you look at most of the bridges, it's based on a message-based protocol that you send a message actively from one chain, and you know the other chain receives a message, and the message can do a bunch of things like cross-chain function call and all that stuff. But what you cannot do in most of the bridges is to basically have this on-demand random access to any on-chain state, including events, transactions, and also storage state, which is basically historical, you know, values on various different smart contract variables, parameters, the ownership of NFT, and stuff like that. So this type of thing is very powerful in the sense that, you know, from kind of a blockchain's perspective, using ZK coprocessor, it can not only just like only access its own state in the past, but also have a omni-chain view and global view for other chains, you know, that it connects to, as long as there is a way to have a verified block header bridged from or kind of relayed from one chain to another using various different means. The block header itself can also be bridged and verified using ZK Proof itself. You can use you know, ZK Light client for Ethereum, or even ZK full consensus client for Ethereum, so that other blockchains, not only layer 2s, but also many other alternative layer 1s, can also trust-freely access Ethereum states. And even in entirely different VM stack, you can have a Solana VM that be able to access Ethereum you know, state, which can enable a lot of exciting stuff.
Just to expand really quick on something Mo said, I think people in crypto don't appreciate typically the power of a block header. Fundamentally, what a block header is a commitment to the chronology of a chain, which means that anything that has ever occurred in that chain from any historical block is provable with respect to that block header if you have sufficient compute and sufficient proving power, which means you can go back you can prove the inclusion of a transaction at Genesis, or you can prove the inclusion of a block header at Genesis, or any transaction of the chronology of the chain, and you can prove the inclusion of composite properties on top of that. Which means that as long as you have ways to authenticate block headers between chains, which is something that we have in crypto continually developed great infrastructure around, all the way from ZK bridging to MPC-based bridging to light client-based bridging, as long as you can authenticate that block header, you can inherit that authentication mechanism for any computation over the state of that chain.
Awesome. More do you want to add on this?
Sorry, which one?
Oh, the GameFi and Gamify.
Oh, Gamify. Okay.
Yeah.
Yeah, sure. I can kind of you know take on this. So yeah, so basically Gamify and you know in general any kind of user facing or mass adoption you know oriented applications one thing that is really missing in Web3 today is something called user experience personalization. So this is something that we see every day in internet applications. It basically says that the user experience for each individual users is tailored based on the historical user data, such as users' preference, historical in-app behavior, what's the lifetime value for this game player, and many, many more. Right, so this is arguably the most important UX design principle in internet today. If you think about it, like Twitter, Facebook shows us different feed, different set of recommended content based on our social networks, likes, and search behavior. Game players, especially when you open a game, different people receive different type of promotions based on whatever like the historical engagement they had. There is actually very, very complex, like there are game companies entirely built based on the principle of data-driven live ops. That is basically to treat each and individual every user as a kind of a data engineering object to basically kind of fine-tune the user experience, fine-tune the engagement level of each user based on their interaction and historical behavior in the game. And even just like for banking apps, if you think about it, like you see special promotions in your finance and banking app because like they have also access and the visibility of your existing behavior in the application. And so this is like what happens in Web 2, right? So Web 2, every data is actually siloed in each individual apps. In theory, Web 3 gives us better opportunity to do this type of user experience personalization because every data is in the open, right? So imagine you are a new DAX and you want to start to engage in the personalized users based on not just your data, but also you can actually look at what is the Uniswap data, who are the big traders, who are the big whales on Uniswap, who are the big whales on PancakeSwap, and be able to attract them into your application. These type of opportunity is not available actually in Web 2, but it's actually possible in blockchain. The reason that people haven't really used this is because there isn't really a good way to allow smart contract to have this type of trust-free access to historical data, and not only just to a single smart contract, but to any smart contract that is available in the chains and in other chains you have access to. Right, so and for GameFi especially, right? So there should be ways to essentially optimize user experience and call back users, engage users better based on their historical behavior to basically say, okay, if you have done this much, if you have played this much game, you will be eligible for participating in this exclusive campaign or exclusive like kind of a game venture. So these type of things are just simply not available in blockchain. But we think that ZK coprocessor can actually enable that and transform how user experience is designed in Web3.
Yeah, I think that was very well put by Mo there. And one thing I just wanted to add is I think when we look at the use cases of ZK coprocessing, one of the overwhelming themes that we have seen across all of these is customization. How do I ensure that I am able to incentivize my most loyal users to continue to use my application? We have heard continued concerns in crypto over how we can incentivize retention. This is why our industry is plagued by vampire attacks in a way we seldom see in other industries. What coprocessors offer is the capacity to in-bake features into your contract logic to incentivize the continued usage of your application by your critical user base. From gaming to DeFi to GambleFi is going to be the next one up here I can see. Yeah, this is one of the overwhelming themes. I think you'd call that live ops in gaming, you'd call that trader discounts in DeFi, or VIP programs in DeFi. We've seen these be incredibly prevalent in the Web 2 context, and now we're seeing coprocessing open up applications to be able to do this on-chain. And so from there, Gajesh, I can segue into GambleFi, or I don't know. Awesome. So one of the very interesting things that you frequently see in gambling-based applications or casinos is rebates for traders that have lost, sorry, it would be for participants that have lost money. If you go to a casino in Vegas and you are one of the most frequent gamblers and you lose a large amount of money, they'll rebate you 10, 15% so you come back and do it again. These are one of the most commonly used retention mechanisms, and they are incredibly important for developing loyalty among your user base. And so in line with that, we typically see on-chain casinos and on-chain gambling activities fail to actually access that type of data to be able to create those types of experiences. If I have an on-chain poker game, or I have an on-chain like RNG-based slot game, or a prediction market, and I want to incentivize people to come back if they lose money based on the fees that would otherwise have been paid in or paid to my protocol, I can't do that. I can't determine who's lost $100 million and who's lost $100. And so with a coprocessor, the awareness over historical data allows you to start building these comparable features that you have traditionally seen at Caesars.
That's awesome. Cool. So like I think NFTs is also like discounts is universal at this point. Like based on your activity, you can discount like NFT mints and things like that.
Yeah.
On-chain incentives, yes. Like for example, if you hold like a pudgy, you're going to get like 10% more. Like right now there are like so many airdrops towards these pudgy holders and like all these like NFT holders. Instead, like if there was a way to like incentivize them on a longer scale, should be really interesting. Like with coprocessors, also whitelisting. Like if you have an NFT, you can get into certain mints. Account abstraction. Thing like Ismail or Mo can take on this.
I can answer this. I don't want to suck the air out of the room here, so I'll answer this, and I want to make sure Mo gets a chance as well. But yeah, I mean, account abstraction comes down to the basic idea that we were discussing earlier about being able to access the chronology of a chain directly through that block header. Chain abstraction, account abstraction, storage proof-based bridging, smart recovery, a lot of this boils down to how can I prove some series of properties about a cross-chain state by using an authenticated block header that I have moved between chains. And so you can allow a user to decision something based on their L1 balance on any OP rollup today simply by using the block header that's accessible in the execution client. You can do this through moving block headers between chains by any cross-chain protocol or bridging protocol, etc., by simply checking storage or event inclusion on top of those routes. And this means that you can build interesting chain abstracted applications that have complicated logic that would otherwise not be possible to codify on chain without using coprocessors. So put concretely, you can simply check if a user has locked sufficient USD on another chain that it should be withdrawable on one of n other chains.
Absolutely. Do you want to add something to that?
Yeah, I mean, those are definitely great examples. And, in terms of account abstraction and also kind of NFT, I think, one other thing or one other kind of a general category that is really pertaining to that is some sort of an on-chain identity, right? So, NFT especially, and also interaction in historical interaction actually defines who a user is, not just from a kind of application perspective, but from kind of just each user's perspective. You can actually generate your identity based on your on-chain interaction, and you can take that identity anywhere you go, right? So like, so you can actually, self-prove that you are for example, big whale, big trader, and then you can take that identity to other chains and other protocols to get a certain benefit. So that's something that is also definitely possible. And also on the account abstraction side of things, one biggest benefit of a smart wallet and a smart contract-based wallet is you are supposed to be able to kind of recover the wallet easier, even if you lost the admin access key. The idea is that you should kind of shard several recovery key to several different places, but oftentimes it's a case that your main key is still there, but the recovery key has already been gone, right? So one way you can solve this is again using coprocessor to prove that historically you have interacted and sent significant amount of funds to certain wallet, which indicates that you actually know and are familiar with these addresses you sent fund to, and these addresses can later dynamically become your recovery addresses based on the recency of the interaction, right? So this is kind of a very, very concrete example, but it's also kind of a pertaining to how you define your identity, how you define others' identity by having coprocessors access and compute based on historical data. So that's just another example to add on.
And I love the credential use case, and so thank you for calling that out, Mo. I think the use case of being able to demonstrate indelibly to a contract that you've met some predefined set of conditions based on the time that you've interacted on some chain is a primitive that we have today in crypto, right? We see Galaxy campaigns and Galaxy credentials and all of this be incredibly interesting to retail users. We just have yet to be able to codify any of this logic in a contract. We have to rely on an off-chain entity to issue it.
Perfect. Awesome. We can actually head to the Q&A session now. Does anyone have any questions or anything? Cool. We can actually get into the breakout sessions in that case. Cool.
Sure.
I opened 2 rooms. Yeah. One is assigned to Lagrange and one is assigned to Brevis. So if anyone has like more questions or like want their protocols, like want to integrate with Lagrange and Brevis, like feel free to jump in these rooms.
All right, I should be in room 2, I guess.
Yeah.
Room 1 is Lagrange.
Yes.
How do I join the room?
Oh, let me just actually invite you there. Which one do you want to go to?
Either one works. Whichever one has
Awesome.
less people, I guess.
Cool.